Hi, I'm Sriram and I'm representing Team 4 and we are going to talk about the insights on cloud application. First, let's come to the challenges. One of the essential characteristics of cloud is to provide rapid and self-serviced unilateral provisioning of resources. However, cloud service providers usually exploit that services scale out automatically. Thus, it is not uncommon that customers pay more than they intended to because they inadvertently leverage this feature of automated scaling and get billed more than what they can afford. This was discussed during our guest lecture, and I feel that the implementation of monitoring and metering schema of cloud is far from flawless. Next, there are some security issues such as trusting the VM image, hardening hosts, and securing the inner host communications. These are critical in the IaaS. Next, accessing your data when you need it's a basic requirement for many organizations. The challenge with the cloud is that data is accessed via an internet connection rather than a local connection. So, when the network of our internet connection is down, it means that the cloud services are also down. So, data cannot be accessed. Now, there are some ways to handle this, like the geo distribution and ubiquitous network access, and the resiliency technique, where failures will be common at scale. The network infrastructure must be fault tolerant against various types of server failures, link outages, or server rack failures. So, designing the cloud solutions, keeping these in mind, will help to build resilience and tackle those issues. Next comes scalability. So the next network infrastructure must be able to scale to a large number of servers and allow for incremental expansion. Then virtualization allows the entire VM state to be transmitted across the network to migrate a VM from one physical machine to another. A cloud computing host service may migrate VMs for statistical multiplexing or dynamically changing communication patterns to achieve high bandwidth for tightly coupled hosts or to achieve variable heat distribution and power availability in the data center. Next, improving energy efficiency is another major issue in cloud computing. It is estimated that the cost of powering and cooling accounts for 53% of the total operation expenditure of data centers. Finally, the storage technologies. Software frameworks such as MapReduce and its various implementations, such as Hadoop and Dryad, are designed for distributed processing of data intensive tasks. As mentioned previously, these frameworks typically operate on internet scale systems such as GFS and HDFS. These file systems are different from traditional distributed file systems in the storage structure, access pattern, and application programming interface. In particular, they don't implement the standard POSIX interface and therefore introduce compatibility issues with various vendors. Next, we are going to talk about the emerging solutions. So, machine learning is widely used on the cloud. Examples are Google TensorFlow, Google Prediction API, Amazon Machine Learning, IBM Watson Analytics, and so on. One of the reasons why ML is moving onto the cloud is high variable workload. Large amount of processing power is needed while you are training your model, and very few resources while running the model. Cloud provider like Amazon can spin virtual partitions when needed and turn it off when they are not needed. At the moment, cloud containers are a hot topic in the IT world in general and security in particular. The world's top technology companies, including Microsoft, Google, and Facebook, all of them use them. Although it's still in the nascent stages, containers are seeing increasing use in production environments too. Containers promise a streamlined, easy to deploy, and secure method of implementing specific infrastructure requirements, and they also offer an alternative to virtual machines. Next, the needs need to be addressed related to infrastructure as a service. And next, um, disaster recovery as a service. So the IBM Resilience Disaster Recovery as a Service can provide end-to-end integrated services using private, public, and/or hybrid cloud. These services provide continuous replication of critical applications, infrastructure, data, and systems to the cloud, so you can recover within minutes of an outage. Intelligent orchestration offers a unified DR management approach that delivers real-time readiness validation. Then virtual machines on cloud. This we have talked about earlier. And finally, cross-cloud security. This is a required need to secure multiple cloud environments by encapsulating data. This currently led to black packet computing. You can research more about these concepts. Expected developments in 5 years. Hybrid cloud services have been pitched as the best way for an organization to meet regulatory compliance while benefiting from the scalability of cloud. It makes it easier for organization to bring existing infrastructure into the equation by not requiring a total rip and replace approach. Then flash memory arrays, as other teams talked about, it's pretty costly, but it can be used for accessing meta table searches, providing greater storage performance and scalability. And when it is properly designed, it can help to reduce cost. Then rise and adoption of bring your own devices. So more and more devices blur the line between personal and professional use, and this is partly because of the flexibility of cloud services. And for this reason, organizations should be implementing bring your own devices policies now. Then enhanced security. So being able to guarantee security in the cloud is essential for cloud providers of any size. Identity access management solutions are set to become a key piece of middleware within cloud ecosystems. We have talked about it enough in the Thought Lab and the OpenStack architecture. Now, the new standard for application execution environments is containers, and it will revolutionize the practices of enterprise IT. The thing about containers is that they are much more easily migrated among groups and facilitate continuous delivery. We expect to see containers emerge as the foundation for enterprise IT re-engineering efforts once it becomes clear that attempting to accelerate application delivery timeframes is impossible if every group begins by rebuilding virtual machines and installing application components. So, what impact can we expect? So, in the US today, 3.9 million jobs are associated with cloud computing, and more than a quarter million of them in IT, according to Forbes. The median salary for IT professionals with cloud computing experience is 90,950. Now, currently, there are more than 18 million cloud computing jobs worldwide, and 40% located in China. With various capabilities provided through cloud applications like remote access to an individual through mobile systems, management, cloud-based softwares, this can increase the productivity of consultants. Now, what could we expect from the class? While a breadth of topics related to current state-of-the-art software was covered, even while executed with Thought Lab infrastructure, we would have loved to experience if we had been given more hands-on training on the same. We also felt that more time could be spent on teaching virtualization concepts with a demo of virtualization concepts such as containers, and the lecture slide content could be improvised to have better understanding of the topics. As I said earlier, we had a good breadth, but we could have some more deeper understanding on the theory, and this could be done through more practical exposure. These are our reference. Thank you, and I would like to thank my team for helping put up this slide.